Today, we're going to be talking about using the general power formula for integration. The formula for this will be the integral of u raised to the power of n of du is equal to u raised to the power of n plus 1 over n plus 1 plus the constant of integration. Let's try this example. The integral of 3x plus 2 all raised to the power 4 of dx. Assign u value which will be 3x plus 2. Du now here would be 3 dx. Dx now here would be du over 3. Now substitute it back to this equation and you will get the integral of u raised to the power of 4 dx here would be du over 3. You can put the 3 outside the integral which make this 1 over 3 the integral of u raised to the power 4 of du. Now you can see here you can now integrate it according to the formula, so you will get 1/3 multiplied by the integral of u raised to the power 4 which will be u raised to the power of 5 over 5 plus c. Simplifying this further, you will get 1 over 15 multiplied by u raised to the power of 5 plus c. Substitute u back into its original form, so the final answer would be 1 over 15 multiplied by 3x plus 2 raised to the power of 5 plus c. The integral of 2x minus 1 raised to the power of 3 dx. Assign u value which will be 2x minus 1. Du would be 2 dx. So dx here would be du over 2. Substitute it back, you will get the integral of u raised to the power of 3 dx which would be du over 2. Put 1 over 2 outside, so you will get 1 over 2 the integral of u cube du. Now take the integral, you will get 1/2 multiplied by u raised to the power 4 over 4 plus c. Simplifying this, you will get 1/8 u raised to the power 4 plus c. And substitute u back into its original form which will be 1 over 8 multiplied by 2x minus 1 raised to the power of 4 plus c. The integral of 4x minus 5 raised all to the power of 6 of dx. U here would be 4x minus 5. Du would be 4 dx. So dx here would be du over 4. You substitute it back, you will get 1 over 4 the integral of u raised to the power of 6 of du. Take the derivative of u over 6 which will be u raised to the power of 7 over 7 plus c. So 1 over 28 of u raised to the power of 7 plus c. Substitute u back into its original form, you will get 1 over 28 multiplied by 4x minus 5 raised to the power of 7 plus c. Let's try this example. The integral of x squared plus 1 all raised to the power of 2 multiplied by x of dx. U here would be x squared plus 1. Du would be 2x dx. So dx here would be du over 2x. let's resubstitute it. So you will get the integral of u squared x, and multiply this by the value of dx, which will be du over 2x. As you can see, this 2x will cancel, so you are left with the integral of u squared multiplied by du over 2, which you can put it right outside. So you will get 1/2 the integral of u squared of du. Take the integral and you will get 1/2 multiplied by u raised to the power of 3 over 3 plus c, and the final answer would be 1 over 6, and u here would be x squared plus 1 raised to the power of 3 plus the constant of integration. The integral of 3x squared plus 5 raised to the power of 4 multiplied by 2x dx. U here would be 3x squared plus 5 du, or the derivative of u, which will be 6x, and multiply this by dx. So dx now here would be du over 6x. Let's substitute it back and you will get the integral of u raised to the power 4 multiplied by 2x multiplied by dx, which will be du over 6x. 2x divided by 6 of x will be simply 3. So it will be integral of u raised to the power 4 multiplied by du over 3, which you can put 3 outside. So you will get 1 over 3 the integral of u raised to the power 4 multiplied by du. Take the integral and you will get 1/3 of u raised to the power 5 over 5 plus c. Final answer would be 1 over 15, because 3 times 5 is equal to 15 multiplied by u5, which will be 3x squared plus 5 raised to the power 5 plus c. The integral of x cubed plus 1 all raised to the power of 2 multiplied by x squared of dx. Take the u value first, which will be x cubed plus 1. Derivative of this will be 3x squared dx. Dx now here would be du over 3x squared. Substitute it back and you will get the integral of u squared multiplied by x squared multiplied by dx, which will be du over 3x squared. This x squared will cancel each other out, so you are left with the integral of u squared multiplied by du over 3. So the function will now seem like 1 over 3 the integral of u squared multiplied by du. Take the integral and you will get 1/3 multiplied by u raised to the power of 3 over 3 plus c. Final answer would be 1 over 9 multiplied by x cubed plus 1 raised to the power of 3 plus c. Try this. The integral of sine x raised to the power of 4 multiplied by cosine of x dx. U here would be sine of x. Du would be the derivative of sine of x is cosine of x. Multiply this also by dx. So dx would be du over cosine of x. So the function now would look like the integral of u raised to the power 4 multiplied by cosine of x multiplied by dx, which will be du over cosine of x. The cosine of x will cancel each other out. So you are left with the integral of u raised to the power 4 multiplied by du. The integral of u raised to the power 4 would be u raised to the power 5 over 5 plus c. So the final answer would be u here is sine of x raised to the power of 5 over 5 plus c, or 1 over 5 multiplied by sine of x raised to the power 5 plus c. Now, the integral of cosine of x raised to the power of 3 multiplied by sine of x dx. U here would be cosine of x. Du would be the derivative of cosine of x is negative sine of x dx. So dx would be du over negative sine of x. The integral now would look like the integral of u cube multiplied by sine of x, and dx would be du over negative sine of x. The sine of x will cancel each other out, so it would look like the integral of u cube multiplied by du over negative 1, which you can put outside. So the integral would look like negative integral of u cube multiplied by du. The answer now would be negative u raised to the power 4 over 4 plus c. Resubstitute it back to its original value and you will get negative cosine of x raised to the power 4 over 4 plus c. Let's try this example. The integral of sine raised to the power 5 of 4x multiplied by cosine of 4x dx. Now, let u here be 4x and du be 4 dx. Dx now here would be du over 4. So the value would be the integral of sine of raised to the power 5 of u multiplied by cosine of u, and dx would be du over 4. You can put the 4 right outside, so the function would look like 1 over 4, the integral of sine raised to the power 5 of u cosine of u multiplied by du. So, in order to solve this integral, you must also use another correction factor. So, based on this integral, inside of integral, assign another u to be the most complicated one, which will be sine of u, because it has the raised power of 5. So u here would be sine of u, and derivative of sine of u is cosine of u du. So dx now here, du now here would be du over cosine of u. So as you can see, cosine of u will cancel each other out. So the integral would look like 1 over 4, the integral of u raised to the power 5 of du, which if you take the integral of it, it will be 1 over 4 multiplied by u raised to the power of 6 over 6 plus c. So the final answer would be 1 over 6 times 4 is 24, and multiply that by resubstituting u back, which will be sine of u raised to the power of 6 plus c, and this u here corresponds to the original u, which is 4x. So resubstitute it all again back, so you will get 1 over 24 multiplied by sine of 4x raised to the power of 6 plus c. Let's try this integral. 4x cubed plus x multiplied by the square root of 4x squared plus 1 dx. Now, first, before you use the u substitution, you must first simplify this expression. So it will be the integral of 4x raised to the power of 3 plus x multiplied by the another term for square root is raised to the power of 1/2. Square root of x is equal to x raised to the power of 1/2. So, based on this, in order to simplify further, factor x out of this expression. So it will be x multiplied by 4x cubed divided by x is 4x squared. X divided by x is 1. And copy the rest, so you will get 4x squared plus 1 raised to the power of 1/2 of dx. So you can see these two are similar, so you can combine like terms. So it will be the integral of x multiplied by 4x squared plus 1. Now, if there is no exponent here, it is automatically 1. So 1 plus 1/2 is 3 over 2. So it will be 4x squared plus 1 raised to the power of 3 over 2 dx. Or rearrange this, the integral of 4x squared plus 1 raised to the power of 3/2 of x dx. Now, you can finally do u substitution. So, let u here be 4x squared plus 1 du be 8x dx. So, dx now here would be du over 8x. So, rewriting this, you will get the integral of u raised to the power of 3/2 multiplied by x. Dx now here would be du over 8x. The x will cancel each other out. So you are left with the integral of u raised to the power of 3/2 multiplied by du over 8. Let me just rewrite this. The integral of u raised to the power of 3/2 multiplied by du, and put 1 over 8 here, because once again you will put this outside. So you can finally integrate this. 1 over 8 multiplied by the integral of u raised to the power of 3/2 is u raised to the power of 5 over 2 over 5 over 2 plus c. Simplifying this further, you will get 1 over, simplifying this further, and you will get 2 over 40 u raised to the power of 5/2 plus c. So the final answer would be 1 over 20 multiplied by u, which will be 4x squared plus 1 raised to the power 5 halves plus c.